What you need: milk, dish soap, tincture of iodine, a few cotton swabs, and a plate. Pour enough milk to cover the bottom of the plate. Then drop the tincture of iodine onto the milk. Dip a cotton swab in the dishwashing detergent liquid and see what happens. Do you know how it works? When you introduce detergent to the milk, several things happen at once. The detergent lowers the surface tension of the liquid so that the red substance is free to flow through the milk. The detergent reacts with the protein in the milk, altering the shape of those molecules and setting them in motion. The reaction between the detergent and the fat forms micelles, which is how detergent helps to lift grease off the dirty dishes. As the micelles form, the pigments in the tincture of iodine gets pushed around. Eventually, equilibrium is reached, but the swirling of colors continues for a while before stopping. What will you need? Dry ice, a bowl full of water, a piece of cloth, and dish soap. First, put some dry ice into the bowl that is full of water. Then, soak the piece of cloth in the dish soap. Then, using the piece of cloth, form a bubble which will keep the vapor inside. Start waiting and watch while the bubble is getting bigger. Dry ice is carbon dioxide in its solid form. At temperatures above 56 degrees, dry ice changes directly from a solid to gas without ever being a liquid. This process is called sublimation. When dry ice is put in water, it accelerates the sublimation process, creating clouds of fog that will fill up your dry ice bubble until the pressure becomes too much and the bubble explodes, spilling fog over the edge of the bowl. What you need: test tube, gummy bear, potassium chloride, and heater. When potassium chloride is brought to a high enough temperature to melt, it turns into liquid state and decomposes to produce oxygen and potassium chloride solid. As the gummy bear is a source of sugar, which is a carbohydrate and therefore contains carbon atoms, when the gummy bear is placed into the test tube with the oxygen and potassium chloride solid, it rapidly burns. Anything with high levels of carbon will burn when put into an environment with lots of oxygen and heat. The heat comes from the high heat required to melt potassium chloride to oxygen from the decomposition of the salt. And this is how we explain the reaction chemically.